Have you ever heard the phrase, "Is the glass half full or half empty?" For centuries, people have used this simple metaphor to separate optimists from pessimists. But what if we took the phrase literally? What if half of a glass of water wasn't filled with air, but with nothing at all? A real vacuum. Today, we'll break down this mind-bending scenario using physics, pressure, and a bit of imagination. And trust me, the pessimist might actually be closer to the truth. Traditionally, when we say half full or half empty, we're describing the same situation, a glass with water in the lower half and air in the upper half. Optimists highlight the presence of water. Pessimists emphasize the absence of it. But linguists point out something interesting. The phrase also depends on context. If a glass is being filled, you'd naturally call it half full. If it's being drained, half empty. But in science, words alone aren't enough. We need to know what's really happening inside the glass. Now let's get weird. Imagine at time t equals 0, the air in the top half of the glass suddenly disappears. Not replaced with helium. Not with carbon dioxide. Just gone. A true vacuum. Immediately, physics takes over. Molecules, pressure, and even the structure of the glass itself are about to face some serious chaos. To explore this, we'll look at 3 different versions of our half-empty glass. 1. The normal glass, water at the bottom, air on top. 2. Vacuum on top, water at the bottom, but the air above it is gone. 3. Vacuum on bottom, the top half looks normal, but the lower half beneath the water is replaced with vacuum. Each version leads to very different, and very dramatic, results. At first, nothing seems to happen. Air molecules usually zip around at hundreds of meters per second, but in those first millionths of a second, they barely move. Then, the fastest molecules break the stillness, shooting into the vacuum. In the vacuum on top glass, water begins to boil instantly. Not because it's hot, but because in a vacuum, liquid molecules escape freely into the empty space. In the vacuum on bottom glass, the pressure imbalance is catastrophic. With nothing supporting it, the water and glass above slam downward. And in the ordinary air-water glass, nothing dramatic. Just business as usual. Within a few milliseconds, everything changes. The rushing air collapses into the vacuum, slamming into the water and creating a pressure wave, a mini shockwave. The glass walls bend slightly but don't break, yet. The wave echoes back and forth inside the glass like sound inside a drum. To nearby ears, it sounds like a sudden bang. Meanwhile, in the vacuum on bottom glass, things get much worse. As the unsupported water crashes down, it hits the bottom of the glass with incredible force. Water is nearly incompressible, so the impact doesn't spread out gently, it slams like a hammer. This effect, called the water hammer, is the same phenomenon that makes old plumbing pipes clunk when you shut a faucet quickly. But here, the force is so extreme that the glass doesn't stand a chance. The bottom shatters instantly, sending shards and water spraying outward. The destruction doesn't stop there. The broken lower half of the glass slams into the table. The water splashes everywhere. And the top portion of the glass, still intact, shoots upward thanks to the imbalance in air pressure. If the ceiling is low enough, it smashes into it, shattering into fragments before raining back down. All this happens in less than a second, far faster than a human can react. What started as a quiet metaphor for optimism versus pessimism ends in flying shards and explosive noise. So, what does this thought experiment tell us? 1. Physics always wins. Even harmless sayings hide surprising science. 2. Pressure matters. We live at the bottom of a sea of air, and most of the time, we don't even notice. 3. Optimist or pessimist, both would probably agree, if your glass is half vacuum, you're in trouble. So the next time someone asks you if the glass is half full or half empty, you can smile and say, it depends. If it's half vacuum, it won't last long. Don't forget to like this video, subscribe for more mind-bending science questions, and drop your own what if scenario in the comments below. Who knows? Your question might be the next one we explore. Because in science, the glass is never just half full or half empty. It's full of possibilities.